Today we are going to make bats using shader magic to flap the wings. No bones or joints in this one. I'll be adding to the awesome portal effect that Benny made, to which you can find the link to the video in the description box below. Let's get started. Hi, I'm Jessi Sparrowhawk. I'm with Beyond FX, and Maui is going to help us. For this tutorial, you should already know how to use Unity and should be familiar with making shaders and particle systems. I'll also show how to make a quick flipbook in EmberGen. For material creation, I'll be using Amplify Shader. It's a plugin on the asset store, but you can use whatever material editor you're comfortable with. There's nothing plugin specific in this example. First things first, we need a bat mesh or some kind of winged creature. My husband made this super awesome bat mesh. It has a color texture and a normal map. Both are totally optional. You can just make it a simple mesh. It doesn't even need to be this many polys, but I thought it would be fun. Obviously, if you have more polys in the wings, it's going to animate nicer. So we have an unwrap here. When we get to doing the material, we're going to need a different view here because to run a mask across this would be pretty messy. So I made a second UV set that is just a top-down view of the bat. And later, I'll show you how to use the UV coordinates to control how the vertices are animated. Okay, now it's time for Unity. Once you get your model in here and your texture and all that, let's look at this particle system first. This is an isolated system I made to make it easier to see what's going on. So basically in the renderer, we make sure to plug in our bat mesh and the material we're about to make and make sure the render alignment is set to velocity so it rotates in the direction it's moving. And then we are also going to want to turn on custom vertex streams so we can pass data into the material. The data that we want to send is, by default, position, normal, color, UV should be there, but we want to also read the second UV set. We want the center of the particle, so we know where it is in space, and the velocity, so we know where it's moving, and then some custom values to which we will be animating the wing flap from there, as well as bloom emission later on. So moving on to the material, let's break this down. So we have a standard surface shader here, set to opaque and alpha test. We don't need soft transparency here, and everything else is default. This is where the data is passed from the particle system, and I like to plug the data into local variables to make less of a spaghetti mess of my material. Here we have both the UV sets and the center of the particle, the rotation or also velocity, the wing flap, and the bloom. Here is the color setup. We have just the regular unwrap UV plugged into the texture. We have it multiplied into the particle color so that you can change it to different color bats if you want. And then also multiply it into bloom, which goes to emission, and up here is the regular albedo color. We also have the particle opacity multiplied in with the opacity of the texture because there's little hairs on this bat. And this is where it gets good. We're not using a rigged model for this effect. Bones can be expensive and we want a lot of bats on the screen, so vertex animation is going to work great for this. To start, we need to define what vertices need to be animated because we don't want the whole bat to move up and down. We just want the wings. So we're going to make a mask here. This is the top-down UV set. We grab the X coordinate, which creates a horizontal gradient, multiply it to make it a bit stronger, right here. Multiply it by tau, which is 2 times pi. Plug it into a sine node to make the gradient symmetrical. And then we have a multiply and a power node so that the material instance can control the strength of the gradient. And then we invert the mask so that the white area is what should be influenced and the black areas is what's ignored. Now, if you only use this mask, one wing will go up and the other one will go down, even though the mask is symmetrical. So what I do to fix that is I make another little mask that inverts half of the mask to be a negative value. So that is this section here. Then we get the flap amount that is passed from the particle system and an additional little tweak value if we want it on the material instance. We multiply both the masks together and the wing animation, and that gives us an animated mask. It is a float value, but we need to plug it into the vertex offset, which requires a vector 3. But if you were to multiply the mask by the vertex position, it would kind of work, except for when the particle rotates, the wings will be all skewed. That's where rotate about axis comes into play. It'll fix the skewing issue. We use the particle velocity or rotation to define the rotation axis. The center of the particle is the pivot point. World position for position. And then we subtract away the world position afterwards so that we don't have a particle going off in a weird place we didn't expect it to. And now it's all ready to plug into the vertex offset. So we plug in all the local variables and also put a normal map in there, and we're ready to go. So back here with the isolated particle system, let's go ahead and turn off this one. And I'll show you what it looks like with the custom modules actually functional. So under the custom module, we make sure for the wing flap to use this handy loop on the curve so that you don't have to hand place a bunch of repetitive keyframes across here. And then later we'll be using this bloom when we have it spawn out of the portal. Super cool. Here we have a real quick look at how you can influence the flight path of the bats or birds using the velocity over lifetime. I just applied some orbital values here and it gives this cool corkscrew path. And then I also use, let's get in closer, I bobble them a little bit on the Z so that it gives it a little extra motion while they're flying through the air. Here's a better look at that bobble motion on the Z axis. And with my mask settings, I allowed for the ears to be in there a little bit just to get a cute little ear wiggle. I'd also like to show you how to quickly add a smoke flipbook that is flexible enough to use for fire. I used EmberGen to create my flipbook. I love how quick and easy it is to make some really nice flipbooks. With EmberGen, I started with one of the default explosions and I kind of just reduced all the extras that I didn't need for it. There's a lot to choose from, so you could like endlessly go through them. I'm not going to go through the whole process step by step, but instead point out some of the key parameters I think makes a good smoke poof. So to start, we have a force, which I'm mostly rendering it top down, so it does, I suppose this one isn't all that important, but what I did use is push strength on this one to keep the smoke from going up too quickly. That's kind of the theme with all of my parameters here, is to make sure the smoke doesn't go up too quickly. And then for the emitter, I make sure to crank up the smoke rate because that is the main feature of our flipbook. Under simulation, we turn on looping and keep it pretty short because it'll be more flexible this way to control the timing all within Unity. The other parameter that's important here is the dissipation, the smoke dissipation. I want the effect to stay pretty compact, not to trail around too much. That way you can make a higher quality sprite. You can fill more pixels in a compact area. And then the last thing under simulation is the buoyancy and smoke weight to also help keep the smoke from moving upwards too fast. And then the final adjustment is under shading, all the way down under smoke density min limit. I increased that a little bit because it helps dissipate it even faster and kind of a little bit more in a stylized way as well. So now we're ready to render. I want to pack as much data into textures as I can. Selecting motion vector, it needs all three RGB channel, but that gives us one channel to work with, so we plug the alpha into that. And then we also want emissive, scattering, and ambient light, all four, to control the color in the material. So for this, we take the red channel of each and plug them into a texture. So that gives us an RGB. We don't need the full color values because we're only going to use them as masks. So that is the steps in EmberGen. So back in Unity, let's go ahead and look at the material that will use the data that we exported from EmberGen. So here we have some data that we're bringing in from the particle system. So specifically the UV, the age of the particle, temperature, so we can control that in the particle, the speed of the Flipbook animation, some bloom, and erosion. And then looking over here for the UVs, we plug those local variables into this material function that I made. Amplify shader, at least currently, does not have a motion vector by default, so I set up one that's more specific to my EmberGen export. I created a material function also because motion vector flipbooks can be used in a lot of places in a project. I'm just going to gloss over the nodes for the motion vector because it's a bit mathy, but at the end result, it's really cool and worth it. So here is the inputs for the UV, the time, the speed that we pass from the particle system. These plug into Amplify's Flipbook node to get the current frame UV. This UV is used to sample the motion vector, which can be masked to act as a distorted UV. The sample is done twice, as you see here. One sample being ahead one frame to smooth out the motion later. And this part it gets a bit fuzzy for me, but it is multiplied by a fraction of the current timing and then multiplied by an influence value, which is right here and exposed in the material instance. This value will help tweak your specific motion vector to help smooth out the motion. So if you're getting stuttering in your flipbook, this is what you should check. So from here, it gives us a new smoothed out UV to sample whatever texture we need. In this case, we have two flipbook textures, the motion vector again, because we need the alpha channel from it, and also the color texture. They are lerped with the timing to here, and we split out the channels that we need separated. So in the material, after the texture is ready, we can apply a color right here for the hot areas and then use the temperature and bloom parameters that are passed from the particle system for the final color. And then for the opacity, we have a depth fade, we have the particle opacity, we have a noise texture to use erosion, which kind of gives a more stylized look to the smoke if we wanted. And that's all plugged in. So here is an example of the smoke, two different particle systems using the same material, but they're using different values in the custom module, to which you can see here we've got the temperature, we've got speed, bloom, and erosion. Pretty cool stuff. Thanks so much for watching. I hope you enjoyed this tutorial series. If you have any questions, please leave a comment below and be sure to like and subscribe.